Hello everybody! If you're new here, welcome. We are working on our kernel from scratch. Last time we started work on the IO Apic initialization. That's what we are going to still be doing today. So let's get to it. Alright, so there are a few things I want to do before we actually get started on the next step. One of which is to actually try to create these bit fields here for identification and for the IO Apic version register, which will allow us to get the maximum redirection entry number, or rather the number of redirection entries that we have. So let's do that. So first, this here is 32 bits, and we start from the very last byte, and we take about 3 bits, or 4 bits rather, to encode the ID. So that would be something like, so let's go over here and do const ID is a backstruct struct that will have so unused or reserved, sure. This would be like a U24, I believe, and then we have ID, which is a U4, and then we should have reserved 1, which is a U4, I think. Right, so that's for the ID. Let's go for the version. So this would also be a backstruct. But this one here will have version. So we have the lower byte is the Apic version. So version is a U8. Then we have the byte above that is reserved. So reserved 0 is a U8. Then we have the next byte would be maximum redirection entry. Let's say that's a byte, and then the byte above that is reserved 1. I believe that's correct. Yeah, that should be okay. The arbitration register, I think we are not going to need it because that's something that's not used anymore, I think. Right, so let's also create this here, the IO redirection table registers, except that this one here we are going to need to split to 2 32-bit halves. Or should we? No, maybe we'll create just one whole struct and have like a function on that to get the 2 halves. Yeah, that sounds good. Right, so const redirection entry is also a backstruct. And this backstruct has, let's go all the way down here, so a vector, vector 1 byte. Then above that we have 2 bytes for delivery mode. Okay, so delivery mode, that's a 2 byte, but let me just write that as delivery mode. Sure, we'll create the enum later. Destination mode, so destination mode, and here I'm just going to make it physical as we did for the Apic. Oh, physical is 0. Right. There we go. And that's 1 bit. Right. So delivery status is read-only. So delivery status is a read-only bit. And then we have input or interrupt input pin polarity, which is a single bit. So yeah, okay. Polarity, which is polarity. I guess we could create that for here. And I think we should give this a value, default value, which would be active high in this case, just because I know that most interrupts are delivered with active high and are triggered on edge. So remote IRR is the next bit, and so remote IRR is the next U1, and just set that to 0 because we don't really care. Trigger mode is trigger mode, and I'm gonna set that to edge. Sure. And then interrupt mask. So masked. This one is just a boolean, and I am going to set this to nothing. Actually, let's force ourselves to specify that. Next would be a bunch of reserved fields. So that's 1 byte. And from 8 to 16 to 15 is the next byte. And then here we have 16. So this would make it so this would be the last byte, I think. And this would make it just shy of 31 bits, I think. So reserved is U31, and that's just 0. Yeah, okay, fine. And then the last byte would be the destination field. Yeah, so destination would be a U8. Okay, so now we just need to create the delivery modes and trigger modes. But actually, I would like to check if so yeah, I would check if these two are not exactly equivalent to the ones we've defined for Apic. But actually, that's not really interesting. So this is an enum backed by a U2, I believe. And we'll see. So delivery mode. Oh, a U3. Okay. So does that change anything here? So we have 8 and 5, that's 13, plus 1, that's 14, 15, 16, 17, and I think we're 1 shy. Oh, no, that's correct. That's correct, because here we go from bit 0 to bit 16, so that's 17 bits. That's correct. Right, so delivery mode. Let's see what we have here. So fixed, and that's 0. And then let me just get all of them. Right, so that's all of them. Let me just double check a few things. So NMI is 4, init is 5, and external interrupt is okay, 7. So that looks about right. So SMI is 2. Yeah, that looks about right. So let's move on to const polarity. This also be an enum. Just checking that this is a U1. Polarity. Yep, that's a U1 with active high and then active low. So U1 with whoops. Let's do this. So active high, that's 0, and then active low is 1. Then the next one would be trigger mode. This should also be a U1 enum. And I guess it's just level and edge. So level triggered is 0, and then edge triggered is 1. And now I am actually in doubt because I think, so earlier I said that by default it would be active high and then edge triggered, but now I am kind of doubting this. So hold on one moment. Right, so no, interrupts by default are usually edge triggered with active high. So yeah, so that was okay. Right, so now that we have done this, we need to actually create public function lower, which returns a U32. And obviously we need also a higher, which also returns a U32 that we can write to our registers. So this would actually need a self, which would be, no, let's call it redirection entry. Same goes here, so self is redirection entry. And here we want a const, so int 64 is bitcast of self, and we want to truncate this to whoops, that's, yeah, that would be return at truncate int. So that's for the lower half. For the higher half, we want to get this, and we want that to be shifted left by 32 bits, I guess. Yeah, that goes here, and then we truncate to get the 32 bits we have there. Sounds about right, I think. So yeah, let's actually get that. So here, I guess we can now just do add bitcast of this to be ID, and here we want ID register.id. So we'll see if this breaks anything. Otherwise, let's also do something like max redirection entry, something like this. Redirection entry self IO Apic driver. This returns a U8, sure. Const version reg is version. Wait, hold on a minute. That needs that. Okay, so where were we? We're here. That would be at bitcast of self.read version, and then we return version reg dot max redirection entry. Right, so this would be a good point to actually try those. So how do we go about that? Let's do log.debug and do IO Apic driver with the ID and do something like version is whatever that is, maybe hex, and max redirection is something like this. Right, so this one here would be driver .id, driver.version, which we didn't yet work on, but driver.max redirection entry. Right, so let's go here, do pub function, version is, well, it takes in itself, IO Apic driver returns AU8, I believe. The version is, and here we just need to do this and burn version. That's AU8. Cool. Right, so I guess now is the time. So let's make -b all and right. So let's try to find where we have that initialized. So driver 0 version is 20 in hex, and max redirections is 23, which sounds about right, I think. So hold on a minute. Let's go here. And that is in fact the maximum redirection entry. So it's not the count, because the count would be the entry plus 1 since we start from 0. But that looks about right. So I'm just going to need to check the actual version. So here they say that version is 11 hex, which should be 17. But we have 20. So yeah, I'm guessing that's of no major impact. So we are going to just ignore that for now and move. Right. Okay. So now that we have this, we need to actually start working on the real stuff, which is actually initializing the redirection tables. So how do we go about that? Well, first of all, we need to know. So here we have IO Apics. These are the IO Apics that we have parsed. And in IO Apic we have, we should have, wait, we don't have that in here. So I guess we also need to pass in interrupt source overrides. Yeah, so we need to pass in interrupt source overrides. But all right, you know what? Let's not get too ahead of ourselves. Right, so here in the initialization here, we return the Apic, but before we do that, we are going to actually do something else here. So just thinking about this, let's do something like const, or never mind, let's keep that there. This calls into that, this inits the IOEpic driver, and here we can do something like driver dot init redirection table. Sure, except that now here we need to pass it the interrupts. So hold on a minute. So here we need to pass it the interrupts. That means that here now we need to find where this is called, and pass it the smp dot in-source overrides. Something like this, or rather, is that an array list? Yeah, so that's dot items. Okay, so that's starting to look like something. So in source src overrides. This would be this smp dot in source override. Okay, so this one here takes in source overrides and should do whatever it needs to do with those. Right, so this one here is the init. We need a public function init redirection table, capital T, please. And here we need self, which is IO Apic driver, and then we need a in source overrides, which is this SMP in source overrides. Cool. This for now just return a void. Yeah. So let's first try something. Before we actually do this, because this is kind of wrong, I think. These interrupt source overrides, they have a GSI, and this GSI should actually, so we, hold on a minute, let me try to formulate this better here. Let's actually try to draw this. So we have IO Apic drivers, so we can have multiple chips handling IO Apics, right? So connected to the system bus. And each of these chips has a base, GSI base. So this one here announces that it wants a GSI base of 0. So this one here wants a GSI base of, so they need to be apart with at least 24, which is the max redirection. So this one here would like to have something like 40, right? Which is far enough for it to work. So here, the interrupt source overrides are defined in regards to the GSI and the source. So basically, we have an interrupt source that maps to a GSI, except that this mapping here needs to go to the table of the IO Apic chip that handles that GSI range. So from this one here handles from 0 to 0 plus 23. So that's this. So that's max this thing here. This one here handles from 40 to 40 plus 23, right? So we need to find which of these handles that GSI. Yeah, so in which range that GSI for that redirect falls before we actually go ahead and map that. And another thing we need to do is actually, hold on, just go back to drawing. So steps we need to take here, just to be safe. One, we need to ID map, so identity map, all the interrupts, so all the pins. So int n will go to something like GSI base plus n, right? So just identity map those. Step 2 is mask all interrupts, just so that we don't get any stray interrupts causing problems. And then step 3 is apply the overrides that are described here. So overrides come in multiple flavors, but overall it's either a redirection, so this interrupt n here goes to some GSI m, or it's still an identity map, but we change polarity and trigger modes. So that's the plan. So what I'm going to do, so here we have two choices basically. We either filter out the in-source overrides to create just a to send to each driver just the overrides it should handle, or we can probably go a more generic route, which is just send all the drivers, all the overrides, and have them pick the ones they should handle. Right, but before we do that, let's actually just do something like this. So this one, I'm just going to get rid of that pesky error. And what I'm going to do is const max redirect entry is self dot max redirect entry. And we are going to just go ahead and do step 1 and 2 that we have discussed. So step 1 is ID map all interrupts, right? And step 2 would be to mask all of them, right? So let's actually do so for max redirection entry, get that as I. Whoops, there we go. So here we need to create. So here we can do actually two things. We can either read this redirection entry from whatever it was initialized as in the IO Apic and then try to change a few things, or we can just actually go ahead and force that. Not sure which one I like more. Yeah, I think I'm just going to force the values here. So right, but before we do that, I think we might also want to move this thing here. Right. So hold on a minute. We should probably go ahead and do redirection count, right? And then this would be something we need to read. So let me just go ahead and do const redirection count is so we need to rely on this with self.read and self.write. But since we still have not created self, I'm just going to do something like this. Just absolutely do this here. Okay. So here reg would be, so what did we call that? Register.version. Okay. Right, so this register dot version stirs. Is that it? No. Okay. Redirection count. Hope you're happy. So this one is register dot version. Cool. Right. So we write that to. Now I'm just going to need to get these. Actually, let's just get these here. Const register select is that, as well as this one here. So const window is that. So register select and window. Okay, so that should be okay. This one is the offset, this one is that, and then here we can just get a window. Cool. And now we have the redirection count. That looks very nice. So now let's get to this. So direction direction entry is let me just type in this redirection entry is so what do we need to get in here? So let me just do okay. Right, so that's that. This one here becomes self dot redirection redirection count. Wait, what's going on? Oh, we haven't defined that. So redirection count is a U8. I think that should be okay. Must have a known result type. So that should be okay. So that's a volatile U32 pointer, I believe. Yeah, both of them. So this one would also be a volatile U32 pointer. So that should be okay. So that means that now we can actually get rid of this, maybe even this. Maybe we can do something like, oops, this, and here we can actually get rid of this by doing a redirection count here. This becomes any. Yeah, that should be okay. Right, so vector would be right, so this one here is also a bit of a problem because we need to go to interrupts. Here we go. So we have 32 reserved vector numbers. So the earliest vector number that we can actually map to should be above 32. Yeah. So that's something we need to take into account. And that should also mean that here, in the interrupt handling somewhere, I wanted to define, as this is in our arc-specific stuff, maybe in here somewhere, context, no. So here I'm just going to define a public, yeah, just about here, public const interrupt system interrupt count. and this one here would be 32. Right, so that's all I want to do here at least, and we can probably go back here and import, so const interrupts, or interrupt is at import interrupts.sig, so that's should take an S, I guess. Right, so here we want interrupts.system interrupt count plus I, right? So that's the vector we want to map this to. And this actually brings me to we need a system to mark interrupts as allocated, right? Some sort of bit field that will let us actually know that this interrupt that we've just taken here is actually used elsewhere, and we shouldn't reuse it in our system, because otherwise that would create problems. As simple as that. Right, so let's actually get this going. What is the problem here? Unused local entry. It's fine. Right, so here I want delivery mode is fixed. Wow. Destination mode, we already have that. So polarity is also already set. Remote IRR trigger mode masked. So actually, let's just combine steps here, 1 and 2, to the same step. I just want to check that masked is actually, so we set 1, we set true to mask. Yep, okay. Right. So masked is true, and destination is I guess we need CPU, right? CPU. Sure. Destination would be CPU.per CPU.id. So we are just going to redirect all of these interrupts we're handling to the current CPU, which should, in theory, here be the BSP. So this needs to only be done in BSP. And that might be something we can, so that is something we can do checks for. So in Apic, well, not this one, so let's go Apic, this one here. So I don't remember which register exactly it is, but I think it should be something like ID, I think. 1 sec. Right, there it is. So here in this MSR, we get the info if we are the BSP or not. So this bit 8 here of this MSR. So that might be something we can save to our per CPU registers and just do a quick check for that. So that might be something we need to do later. So I'll just add that here. So to do check, we are the BSP, bootstrap processor. Right, so now we have this here. We want to write this to the actual redirection table. So for that, I'm just going to create a another helper here. So function read redirection table entry, and we'll see what it's going to take. We know it's going to return this, and it's going to take self IO Apic driver and an I, or an index, which would be a U8. Sure. And I'm just going to do this and write this one here becomes entry, and this one here becomes void. I'm just going to get rid of this window now. Right, so read from a redirection table entry. So first of all, we need to compute the actual register we need to read from. So redirection table register is at int from enum of so hold on a minute, what did we call that? Register redirection table. Okay. So where was I? There we go. So register.redirection table, right? And to this we add 2 times index. And I'm just going to allow myself to add this here. I'm just going to do this, and this becomes like so. The reason for this is because here we have 10 is for redirection table 0, and 11 is the higher bit or higher part of that register. But if we go to some ID n, we go 10 plus 2 times n, and then we get to the lower part, and then 10 plus 2 times n plus 1 gives us the higher part, right? So those are what we have here. And that means that now we can go ahead and read from those. So redirection table low is self.read. And here we want I think that's what we want to do, because now we are going to do enum from int of that redirection table register low, right, and that gives us a U32, and then redirection table high. The high value is self.read enum from int of redirection table register high. Okay, now we just need to combine both of these values here. So redirection table is, so this one is a U64, obviously. So this would be as U64 add int cast of that redirection table high, shifted left by 32. Let's put all of those in parentheses like that, and then we end that with redirection table low, which we don't really care, to cast. And then we return at bitcast of redirection table, which would cast this int here to a redirection table entry, which should be a packed in struct. Yep, correct. Here we are going to do the same thing pretty much, except that now, instead of doing this as a read, we are going to do entry.lower, or lower, sure, and entry.higher. And now we are going to go ahead and write, so self.write to add enum from int of redirection table register low and redirection table low. Same goes here, so I'm just going to do low becomes high everywhere. Right, so I'm just going to check something in the documentation about the order of writes here and if there are any actual side effects to those, which is something that we always need to be wary of when we write to memory mapped I/O. I would actually try to just write the high field first, just to avoid any weird stuff. Same here, I'm just going to read the high field first. Okay, so that looks pretty good. So now we can write our, so write redirection table entry. We have ourselves is that's fine. We have our index I, and we have our redirection entry entry. Of course, here we forgot to do this. Now looks okay. So this here ID maps all entries I to fire to this vector here plus I, except that this is still not totally correct, I think, because we need to add to that our GSI base. Yeah, that might be a lot better now. So in any case, in our test system here, we only have one. So we only have one IO Apic, and it just happens to have a GSI base of 0. So that won't change much for us, but yeah, that would be needed for any more complex systems. Right, so with this, we should probably move on to the in-source override. So let's actually do for in-source overrides and get that as in-source override. Sure, why not? Right, so we want to first start by checking if in-source override dot GSI is not in. So if this is less than our self.gsi base, or if in-source override is larger than self.gsi base plus self.redirection count. Is there an equality here? No, because this is count, so that should work. We just continue here. We ignore this interrupt. Otherwise, we are going to need to act on it. So we are going to probably need to read. Do we need to read the entries? So yeah, let's go ahead. That would allow us to try out our read function also. So redirection entry is self.read redirection entry, which would be ID. So how do we come up with the ID? I think that would be, let's actually write that here. So RQ, just RQ, ID, yeah, sure. This would be int source override. So the GSI minus our base. Yeah. So minus GSI base. So if the base is 0 and we want to map interrupt 8, which is like a timer interrupt, this would be 8 minus 0, but if our GSI base is like 40 and we want to map interrupt 8, this GSI here should be 48. So we need to subtract that to actually get the actual redirection entry that we are interested in. So this one would be RQID. So that allows us to read that. Now from reading that, we need to actually do a few changes. So either on the vector, so const new vector would be so int source override dot source plus yeah, that's not something I'm sure about. So let me just take a look at the example we have. So here we have yeah, so source would be 10 and the GSI would be 10. So all the mappings we have are just changes in trigger mode and polarity, I think. No, we have this one here. So source is 0 and GSI is 2. So this would mean that we need to map whatever source 0 that we have to a GSI of 2. So that's the actual interrupt. And I think we need to pretty much do the same that we did here. So system interrupt count plus GSI base plus whatever that source is would be the vector. Right. So let's add interrupts.system interrupt count plus that source, or plus self.gsi base plus that source. So that's the new vector. So now we need new polarity would be a switch on in source override dot polarity, and that would be if it's so active high, we return active high. Yeah, and if it's active low, we return active low. So that's fairly straightforward. Same goes for the trigger mode. So const new trigger mode is switch on int source override dot trigger mode, and sure, and this goes edge triggered. Whoops, goes to edge triggered, and level triggered goes to level triggered. Oh, and we might also have bus conforming things here. So bus conforming and active high, and here bus conforming and edge triggered go to edge triggered. Yeah, okay. So redirection entry dot polarity is new polarity, redirection. I can do this. Trigger mode is new trigger mode, and redirection entry dot vector is new vector. Is that all we need to change? So let's actually go to this here. So we don't care about bus because the ACPI docs specify that bus should always be 0. So source, GSI, polarity, we have done pretty much all that we need to do, so we can get rid of all of those. And now the only thing remaining is to write back the redirection table entry to RQ ID and with redirection entry. Just trying to reread this to see if there's anything that we did wrong. Yeah, so the only thing I'm not absolutely sure about is this here, having the GSI base in the vector. I think we can remove it. No, I think we can remove it if we have a system that would allow us to allocate interrupts. So we don't need to absolutely reserve all the interrupts for this IO Apic, even though we're not going to use most of them because they're maxed. They're masked. They're not going to be firing. So I might, for now, just remove these, just to not waste vector IDs. And I'm going to upgrade this to a fixme just so that I know that this is something I need to look at. Right, so now that we have this and this, we should probably just run a build to see what we have broken. Quite a few things, it looks like. Expected U8 found U32 for redirection count. Yep, that's fair. That is fair. Because we did not do this correctly. We just read the register. So this one should be version, and this would be version, and this would be at bitcast of that thing. And then this here, redirection count, should be version.max redirection entry +1. Sure. So still not happy. U8 is not indexable. Oh. Of course. So where was that? It was over here. So whoops, 0 to redirection count. What's next? Expect U8 found U size. Right. So this one here would be at truncate. And I guess it's not going to know what type it is. Right, so as U8, something like this, and here I'm just going to do int cast. Or rather, I'm just going to run truncate. Sure. No worries there. And here I should probably go and no, I think that's pretty much all there was there. Right, expect U8 found U32 for the per CPU ID and truncate. Right. What else? So yeah, expect U8 found whatever U size. So let's just do something like this. This would be something like so. Index here and index here. Yep, sorry about that. Okay, how about this? Still not happy. Bitcast size mismatch. Destination type is 64-bit, has 64 bits, but source has 56 bits. What? Redirection entry has 56 bits. Did I miscount these? Oh, I think I've miscounted those. Hold on a minute. Hold on a minute. So 55 to 17 is 38. Yep. So that would explain the missing. Maybe +1. Yeah, +1. 39. Okay. So incompatible types, in source override and U32. Oh, of course. Of course. .gsi. Just forgot that here, GSI. All right. Now, what else? Expect U8 found U2 again. So hold on a minute. RQ ID, where did I find that? So this here, I might add a U8 to that and truncate to this. Okay. Right. Error with comp time value depends. What? Value with comp time only type enum literal depends on runtime control flow. All right. Okay. So this one here would be so IO Apic. No, we are already in that. So this would be redirection entry dot polarity. Yeah. And this would be redirection entry dot trigger mode. Okay. Cannot assign to constant. Okay. How about now? Okay, finally. Let's take a look. Well, the good news is that we still run. The neutral news is that we still have no interrupts firing because they're all still masked. So should we unmask the ones that we override? Huh. I guess we probably should. So redirection, direction, entry.masked is false. This would still not guarantee that we'd get interrupts, but if we don't crash, oh, we got an interrupt. 20. So that's 32. And I'm not sure what that interrupt is mapped to. Do we have these here? So this should be this one here. So GSI 2. So that sounds like, so interrupt 0 looks like the programmable interrupt timer. Except that I'm not sure if we have already initialized that. Huh. So in here, is this what's causing the interrupt? Or is it something else? Actually, hold on a minute. We can debug interrupts. So let's see what happened just before. So servicing hardware interrupt 0x20. So I'm not sure if this interrupt vector here is before or after the IO Apic changes redirection table. Yeah, so I'm not sure. I am not sure. Okay. So let's try a few things here. I'm just going to go to bit. So operating count. So how do we initialize this? I set the counter here to some value, and then we right. Okay, so we do have interrupt on terminal count. So that means that if we don't want an interrupt at all, how do we disable this? So maybe we should just tell it that we don't care. How do we go about that? So, no. So interrupt, there we go. So this byte, it only generates interrupt on channel 0. Is there any way we can disable this interrupt thing? Okay, so let's actually try something a lot less weird. So I'm just going to use channel 1 here for our wait. Hopefully if this doesn't generate the interrupt, that means that the interrupt actually came from bit channel 0. But we still do have the interrupt. So how come? Did I forget something? Right, so there might be something that's wrong here. We need this. So this is the RQID. That looks okay. Now, the main issue I have is with this source here, because we have a source of 0, for example, that we want to map to GSI. And GSI is the global system interrupt, so I'm not sure we are going to be using source here for anything really, other than matching the RQs. So yeah, I'm not really sure why we would need source here. I'm actually tempted to actually just write GSI there. But if I do that, yeah, it's actually kind of weird. So this might need some more studying on my side. I guess we need to, yeah. So this one here, as yeah. So you wait, truncate that. That should build, but still not really sure why we have the exception. Right, so now we do have 22, which is the source 0 redirected to GSI 2. But yeah, I'm still not sure what is triggering this interrupt here. So that might be something I need to look at. For now, I'm just going to remove this and make sure that it still runs without the interrupts enabled. And it does. So yeah, so now we just need to probably go through them one by one and try to see which ones correspond to which entries. I'm pretty sure it's still the bit interrupts that are triggering, but I'm really not sure how or why. That's the main issue that we have. Well, that should be pretty much it for this one. We have worked on the redirection and the overrides, so that should be all for the IO Apic for now. We might want to explore a few topics about interrupt handling again before we move to some more advanced things like scheduling and stuff like that. I would also like to visit or revisit timers to actually create a sort of generic or more robust abstraction on top of different timers so that we can actually get some more use out of these ones instead of just relying on the bit like we currently do. If you're still watching, thank you for watching. I'll see you next time. Fucking out.